Hey everybody, this is Newman, and you are with the Datum Dons. It's Harsha, Unspent, also known as Code Cow, and myself, Newman. Lewis is also here. We meet on Thursdays as a part of a Gimbalabs funded project. Um, we meet on Thursdays to do the Datum Dons. It's a code review activity. And let me explain a little bit about what it's about. Um, One person, and in this case, it'll be Unspent, Code Cow, and he is the Don. He will go through this code line by line. And today we have the Marketplace .ak, the Aiken file validator. He'll go through line by line, and we, the capos or the audience, will basically help him understand or or ask questions ourselves so that we all understand it line by line. Um, it's a fun experience. We'll laugh a lot. We'll go down. We'll open up the uh, documentation. We'll research things. We'll talk things out. It's a great and fun 90-minute ride.
All right, guys. We are going to be talking about the marketplace this week. This code was originally written by Hinson. It's available on the open source mesh GitHub repo. It works right out of the box, and I thought is a good one for us to read for multiple reasons. One, I used it in my own code base, so I got it to work. And two, it's such a common thing. Like this is a DEX, and I think people have a lot of ideas of what a DEX is, and maybe it's like confusing, but it's like, it's 120 lines of code or whatnot. Like that's a DEX is all of this. So I thought it'd be fun for us to learn and kind of just like figure out what it really takes to trade peer to peer on Cardano. So this is, I think, probably the bare bones example of that, like the most basic way to do a peer-to-peer swap, or maybe not the most basic, but there's certainly more complex ways to do it, more efficient ways, but this gets it done. This is a simple peer-to-peer marketplace. So yeah, let's start reading the lines. I mean, we have our import statements up here. And I don't know, Harsha, you liked reading all of these.
So initially I did like to read it, but now all I think we can mention is that we are using Aiken here, and then we are using the vodka library here.
Yeah, okay, good. Yeah, this stuff is Aiken specific, and cocktail and mocktail are both from the vodka library, and that's really used for testing. But yeah, okay, cool. I think you're right. To me, it's better to come to the imports when you use them than it is to just read all of them, like, because it doesn't really help. So
I agree.
Okay, so here's our validator. It starts at line 30. We call it Marketplace. It looks like we have two different types above that. We have a Marketplace Datum, and then we have the Marketplace Redeemer. Okay. So pub type marketplace datum is marketplace datum, which is an object that has a seller of type address. What is the address? That's coming from our Cardano address. Okay.
Okay.
We have a price, which is an int. Notice we don't actually have to import that type anywhere. Right, we don't need this.
Yeah, and what is that? What is that? That's called like a primitive or something that's just baked into Aiken?
Built-in is how they call it.
Built-in. It's a built-in. Okay, right.
Yeah, they also call it primitive, and they differentiate between those. And to me, I don't. They're all like, I kind of think of them as the same.
So I personally think there is a difference. I don't know what the difference is, but there is a difference because not all built-ins we can directly type in, because some built-ins you still have to import. That I tried a couple of days ago and turns out that's the case.
Yeah.
Ah.
So yeah, I think for me, this is one of those areas I kind of just jump over and I just figure it out individually instead of trying
Mhm.
Yeah.
to. Because I, yeah, but right, because int we just don't need to import like that. It's as simple as that.
Correct.
Yeah.
Okay,
Yeah.
so
Yeah.
then we have the policy, which is a byte array, and we learned about that before. And also byte array seems as a built-in because we are not importing that. Okay, so that's a
Right.
marketplace
So
dating.
I have like a question here. Maybe we'll answer this question later when we are going through. But why is the marketplace datum, why does it have like two of these
Two of them. Yeah. Why does
constructors?
it say it twice?
Yeah, great question. I think we will figure that out, but
Mhm.
it's a real good question.
All right, we'll
So
keep it in
what?
mind.
Yeah. Let's keep it in mind. Perfect.
Yeah, because let's go. Let's try to use it. Right. Let's try to use it. Because we know the datum is here, and that gets sent um when the values get locked. Right. Like when the UTXOs are being locked at the marketplace validator. They come with the optional datum, right?
Mhm.
So we look at that. And then when they leave, when they're being spent out of the marketplace, they're going to use the redeemer.
Correct.
So let's look at the marketplace datum right now, and only think about when we're sending things into here, and what should we send those with the marketplace datum, right? So yeah, let's see how we're using the marketplace datum. That's what I want to figure out.
Yeah, when we
Yeah.
come to it, we can get to it. Like we don't have to jump in right now.
So okay, here's our datum.
Hmm.
Our datum opt is here. So we are expecting some datum, and we don't actually care the type here. We're not checking the type. We just want to make sure that it's some, which is why we do the option. But okay, so let's see. Datum, like we extract or we destructure datum here. So now we have this object of datum, and we have its value. So datum.seller we use in is process paid, and datum.price we use. Datum.price is also used to calculate the fee, and then looks like we use the
Oh.
datum.seller to close. Okay,
And from the
so
looks of it, I feel like even if you don't have like that double constructor, I would think it still works because you're directly
And
calling. Yeah.
ooh.
okay, this is good because I agree that confused me because I feel like I write my datums like this. I don't do that nested structure, and I don't know where they. It didn't look like they used it anywhere. They're not destructured. They're not even checking the type here. You
Yep.
know,
Yep. I mean, the
this is
type is already there in the datum in the spend.
it's there. Yeah, it's there, but they're not expecting it, so it's not going to fail if it's not the right type.
Correct. Correct. I mean, it does
Ooh.
fail. It
Yes.
does. Oh, right now it doesn't fail. Expecting. Yeah.
Right? Like it's just expecting some.
Correct. Correct.
So it would fail if this doesn't work, like datum.seller isn't there, like that would fail. But like sometimes you could write that check right here. You could expect that there's a seller in datum, and that could happen here. But let's see. Okay, so I think the only change, Harsha, is this. So
Hmm.
Look
we
at
have
that
these
right there.
double.
Right.
So let's remove these double.
And that's it.
And yeah, because I
Just
think
look. Yeah.
everywhere. Okay, so now I'm gonna you can check this.
Yeah.
And you don't see that? What?
I don't see it. Let's see. Or I don't see it on my live share. Let's see if it's ever in
Oh,
Datum.
there is
I'm
one
trying to
warning here. I see.
open the window now, by the way. You see how that's opening and closing?
Which is
It's
opening and
the window is my size of the window. That's the problem.
oh, I see, I see, I
I
see.
can make it really small for you. See
Yes,
how it
or
just
make it big. Yes, you're right. You're right. Okay.
but you see the error?
Yes, I do. Let me see the error, but this error is in mock address seller.
Why? What's the error?
Let's see. I'm looking for one of the following patterns. Unexpected token seller. Why is that happening?
Oh, isn't that in the Datum?
So this is in line 77. Let's go to line 77. Wait, yeah. So I still,
It's
is it
because,
like the,
right. This is what we're doing. This is what we're doing. So maybe we
Yeah.
could just go back and get a successful test.
yeah.
Just for
Interesting.
scroll your terminal. Right.
Hmm.
So those all pass because I put that back in. And so the question is, what happens if we remove this nested like double thing? Okay. And so the thought is this should work. The validator should work with this. And our test was not failing at line 16. Okay, we were
Yeah.
failing at line 75, which
Right.
is our mock thing.
77. Yeah.
So what I think is you should be able to just do that. And
Yeah.
but what it's not it's failing right here. It doesn't like this. So let's try it again. Right, it's not like in line 76. Because this is a function.
Do you want to take it? Should I just like go to mock datum and see if that has to do anything with it?
I think that is
Uh,
Hmm.
it's this. I think if we just did type market datum.
mock datum.
Oh,
Yeah, we're doing a function mock datum, and then we're piping that into marketplace datum.
Where?
so let me, because it looks like let's. Oh, this. I think Harsh is onto something. I think that
I'm
it
just
has
looking for
something to
mock
do.
datum.
Yeah, I think it has
Let
No,
me.
something to do with the what mock datum takes. I bet that it takes an object of
we
objects or
we
something.
mock datum is our function. It's custom.
Oh, it's a custom function. Okay, okay.
Really? Oh.
Oh, because we defined it. Okay, yeah, you're right. You're right.
So I think if we just remove
Ah.
this and do type marketplace datum, and then
No, no, no.
mock datum.
Because I think we'll be calling that function later in the test, so we
No,
can't change it to a type.
we remove that function. Like stop calling it a function and just call it marketplace datum, or is this a const?
Oh,
I forget. It's like I don't know. I mean, sure,
dude,
sure.
it is. Okay. Okay.
Uh,
Here, so I see what you're doing, unspent, and I like it.
I don't
Because this function, what does this function do? Okay, so answer me that. I mean, I'm not trying to be pedantic. I'm like,
returns
that function,
it
yeah.
returns the datum because right here, right, it's inline datum, and we pass this function.
Yeah, but like, what
And,
is wrong with this function definition? It seems perfectly fine. You call that function, it doesn't take any arguments, and it
right?
gives like
It
market,
returns what,
yeah,
yeah.
with marketplace datum, and then it has these values. Like, I don't see the issue with that at all. Like, I don't know what the
this would be cool if we could change that and make it work. And I think where unspent, yeah, I think if we change that to a type, and then does that set those values? Because basically those values have to be set as, oh, I think I'm beginning to get it, man.
So
So,
how about this? What if we say, let marketplace datum is equal to constructor marketplace datum and this part? Oh shit.
Why can't I type?
So instead of this, let me type it. So we take this.
all right. I think Gullah is on to something.
Oh my God.
What if we just use marketplace datum now instead of this
Oh
guy?
shit. What do you think, unspent? I
I'm
feel like that's
right now. I'm sorry. Give me a second. I
Yeah.
can't
sure, sure.
control the thing. I'm stuck. I'm like I can. Sorry.
Uh-oh. But I think that the two of you are actually on to the same thing. You're basically just saying this function is just returning a constant or a variable. Why not just set the variable? Why use a function to do it? You can just set it, and that we can test that out. That's
Yeah.
cool. Yeah.
I think you need to use const when it's
As
outside.
opposed to let.
Yeah, when it's outside in like the root, it needs to be const.
Okay.
So
And
what was
then-
that? Can you explain the difference between const and let again? Like when
There we go.
Okay. Well, we could look up the official thing, but how I think of it
uh-huh.
is see on line 91.
Mm-hmm.
We can use let because we're inside of this function.
Mm.
Okay, so this is lexically scoped to this function, and for some reason let works. But if we're at the root or outside of any function,
Mm-hmm.
then we need to use const. That's my basic understanding. It could be wrong, but
Yeah. Let's try it out. Let's figure it out and see if
Yeah.
it works. Yeah.
Love it.
okay. So these can't be retyped. It needs to be something like that.
Okay. Oh, yeah, you're right. It can't have a capital letter because capital letters are only for types.
And
Right.
it was the exact same thing. So it'd be like you're reassigning it to itself.
No, but that's the constructor.
No.
Would you need an arrow there? No.
So we defined the type at the top, right? So to build that type, this keyword becomes the constructor, in my opinion.
Mhm.
We filled on line 101. If this works, we're going to get past. Yep, we did it. Okay.
What? It worked?
Well, we got past. So now we
I
change
see.
the mock datums. Oops, I went too far.
Yeah.
And now let's try again, and we got a pass. Okay, so we did it. We officially.
I'm hitting the celebrate emoji.
This was. Okay, so we did two things. So let's recap what we did, because the first thing we did was we removed the nested datum. Okay. There was no specific reason why we needed to do a nested object.
Mm-hmm.
Okay. But
it wasn't a nested object. Like one is a constructor and the other one is like the object name, like,
Yeah.
But they were the same.
Yeah, I think somewhere in the Aiken, in Aiken, they mentioned that like the name of the constructor and like
That's
both of
fine.
them are the same thing. Somewhere I can't remember where exactly. Yeah, I have no idea. What do you say?
I don't know. Where would this be?
That's what I was thinking. Custom types, yeah. Custom types uh, are
Yeah,
defined with the
type
keyword type.
Look at that. That's a nested thing. Both of those are nested.
Oh, oh, look at. Oh, are you able to see it? Because it is. That's a pattern,
Yeah.
a type. Okay, you seeing it?
Yeah, yeah. Are not collection custom types are defined with type keyword. Here we have datum. Blah, blah, blah.
The constructor of datum is called datum, and it has two fields.
Correct.
The constructor
Mhm.
of datum is called datum. And this is kind of what you're saying, Harsha, is it's
Yeah.
one of them is a constructor. So in our case, what's our constructor? It was, do we
Um,
need to, or I guess my question is, but we just removed it, right?
yeah.
Like we, so
So they
why?
mentioned that somewhere as well. Oh, I think it's here because the single constructors are there. There exists a special shorthand notation where the type and constructor have the same name. See?
Okay, it's a
Okay, okay.
shorthand if they have the same name, but the real way to do it is to have both of them.
Yeah.
And you
If
can
you have a
close the whole
different
thing.
constructor and name, that is.
Well, that's a fundamental thing that I just learned. I did not know that. I have always used the shorthand
Yep.
and not even thought about it. And maybe that's okay because they're so commonly that they have the same thing. And so that's why we were able to remove it because we just used the shorthand notation.
Yes. Yes. So just can you just summarize your understanding of this quickly? Like the shorthand and the single constructor name, just so it can become a short. That's why I was asking.
I know. I felt that pressure, and I was like, okay, this is going to be the short.
Oh, we've got an Inception event going on right now.
It's hard to describe. We need. I would look at the longhand notation, and I could describe it. One more. Yeah. Okay. So when you're making a type, you need to have a constructor. Right? I don't know, Harsha. I'm sorry.
Well, there it is. No, there it is. There it is. So in what we saw in the code was type datum. In our other code, it was marketplace datum. And then it was set, and then inside was the same name, marketplace datum, just like here. Did we have named fields
Yes, yes,
in our code?
we did. Yeah.
What were
So
the
let me try to explain.
oh, there were four named fields. Okay. Yeah, go ahead, Harsha.
Harsha's sorry.
Yeah. So
He's
my
got it.
understanding is we are defining a type here. So we use the keyword type and datum is the name of that type. And how do you build this datum type? By using the keyword datum. Or you can use any keyword to build this specific type of datum. But if both the keyword and the constructor are the same, then you don't have to retype it twice. You can use the shorthand notation, which looks like this, where the name of the type and the constructor are the exact same word.
That makes sense.
Bang.
Which is
That's
the
it.
type is the first one and the constructor is the second one? Or is
Mm-hmm.
that backwards?
Yes. Yes. No. Name is the first one, which comes right after type, and the constructor is the second one.
The constructor is the second one. And the constructor would be used to actually construct or build that type.
Correct.
Okay, that makes sense. So in general, though, like these are often going to be the same, and so you can just do the shorthand,
Yes.
which I would read like the type is datum, and you're just kind of the constructor is also datum. You're just
Yes.
assuming. Yeah.
Yes.
Yep. Yep. I mean,
right.
I wonder when they're, I mean, so I'm always, like what's the exception to the rule? Like, is there ever a time when you have a a name, a type name and a constructor that are different? That might be something to
Yeah. When,
because
like, because we could
when do you do?
simulate that easily, but why would you want it, right?
Right, right. Oh, you know what? Maybe.
If there's two of them,
Yeah, yeah.
but yeah,
Well, we
right.
use that type for the spend or the spend type. This is the next one down. Marketplace redeemer and buy and close.
Yeah, what was the
But
question?
so when would it be different? And yeah, okay, he's putting it back to the thing. Now we also have to get the yeah, different constructor. Here we go. Unspent on something. Yeah. You
I mean, that this is the only thing that would make. I guess I'm confused because why would you not just do a different pub type with that
right.
constructor?
And can you,
Right,
is this even like a legitimate way to build a type with two different constructors? Because, so is this saying marketplace can be of the type this, which uses this constructor, or of the type this, which uses this constructor? Or is it like a sum of both these things, but each part needs a different constructor to build?
the only reason I wrote this code is just to illustrate Newman's question of like, why? Why can you name these differently? Why is the shorthand not the regular notation? You know what I mean?
Mm-hmm.
Mhm.
Yep.
So yeah, I'm lost where you are, Harsha. Why don't we look at the docs and figure out what it's saying about this? Like,
Ooh,
it says
what
or
about
okay, yeah, with or without.
well, there you go. It's the next thing in the docs. Multiple constructors.
Oh, there you
Here we
go.
go. There we
Okay.
go. It's like they figured it. I love the feeling of just walking around in the woods and you're like, oh look, a tree. Oh, wait a minute. What's up with this? Oh, there's another tree. It's beautiful. It's beautiful.
Yeah, and then you look down and there's like a paved road. And it's like, oh, I just planted this. Okay, so let's go.
Beautiful. Beautiful.
Harsh, you want to read it?
Yeah. So multiple constructors for a type. Custom types in Aiken can be defined with multiple constructors, aka variants, making them a way of modeling data that can be one of a few different variants. We have already seen custom types with multiple constructors in the language store, like bool or option. Aiken's built-in bool type is defined like this. So a bool can be of the type false or true. And these are not fields, these are both variants. There's a difference.
Right.
Okay, because you see the capital letters in both of these, that means these are types in their own right.
Yep.
Okay.
Yep. Okay.
It's a simple custom type with constructors that take no arguments at all. Use it to
Right.
answer yes or no questions and to indicate whether something is true or false.
So is the true and false are constructors,
Yes.
correct? Yeah.
Yes.
True and false
Constructors
are
are also
constructors,
always start with capital letters.
just like
Hmm.
our different constructor in our example we're talking about.
Yes. Yes. And this I think is a good
That looks more
example.
like it. Yep,
So
yep.
type, which is named user, has two variants. One with a constructor logged in and it takes a field of username, which is of the type byte array. And then there is another variant called guest, which does not have any fields.
Yeah.
And this is how they use it. Let user 1 is logged in and you give it the field and the value. User 2 is logged in, field and value, and the last one is a guest. It doesn't take any fields. I think
So
that's pretty clear to me.
if we go back to the code and we can answer the question.
Yes.
Yes, that is a valid way to construct a marketplace data. Now we're not using the different constructor yet, but that is a valid form,
Yeah.
correct?
Yes.
Yeah.
Because
And these are two
Marketplace and
variants, by
different
the way. This and this
are
are two
variants.
variants. This
Right.
is not like one whole like type. These are just two variants of the marketplace datum type.
Yep.
Mhm. Mhm.
Good.
Love it.
Move to the next part.
And so this next one on 26, this is a type with name marketplace redeemer with two variants.
Correct.
Constructors. Wait a minute. They're variant constructors? There are two
Yes.
constructors called buy and close, and they don't take any fields or details or right.
Yes.
Yeah. Okay.
When
All
you
right,
write
thanks,
that, it takes a field.
And once again, we've achieved a paradox. That was beautiful.
Cool. Okay, so let's
Right.
rock and roll. Let's continue down. We're at line 29.
Yeah.
Right. We understand these are our types, and we've moved back. Let's just we're
Oh,
gonna do the longhand notation. Okay, just to keep it
Yes. Yes.
longhand because that's what Hinson did.
Yes.
So yeah, why don't
so that's got to go back to yeah, there you go. Beautiful. Nice. It's like
Oh,
you've
so
done
we
this type of thing
the
before.
function this needs. Oh, I think no, we didn't correct that. Go back to the function.
Oh, he's gonna get this one. Yeah, there you go.
Yeah, we need another marketplace datum here.
Ah, yeah. Good catch. Okay, you ran the test?
I ran Aiken format. Oh, this is why.
It needs an arrow.
Now Aiken check.
Yes.
Aiken FMT. Oh, look at you with your fancy
Yeah.
fancynesses.
Wait,
What was that?
What is? Oh,
Yeah.
Aiken format. What does that do?
This is the perfect thing that we were talking about earlier. You're walking in the woods. Oh, there's a tree. There's a nice flower. And then you look down. There's a road right there. You just walk on it. Aiken FMT is how you format your code. So it will do all the spacings. It will. It's like prettier format on save.
Oh, so I just do Command S and then it just formats it for me for some reason.
It does that with Aiken.
Yeah. I mean, it does it for me. I don't know if I have something, but like, yeah, just Command S and it does it.
Do you do that for you, Newman?
I haven't ever done it. No, I don't know. I'm not certain.
Yeah, okay. Because I want that feature. I want just Command S, right? Because that's how all the other code works. Everything else I do, it just Command S and it saves and formats. But Aiken was different. So I mean, I didn't do that for months, and then I finally figured it out, and I was like, oh my god, we just have to do this.
Interesting.
So
Okay.
what we learned is that if we want to format our code, Command S, just like on the code editor, you just press Command S. That works for me. But if that doesn't work, you can go to the terminal and type Aiken FMT, which means Aiken format, and that does the same thing. Okay.
Yep. Nice. Good short there.
You shorted it. You shorted it, man. You did it. You're like, I put it in the bank. Put it in the bank. That's an easy one. All right. Okay, but now, so yep.
You ready?
Ready.
Okay. So
let's go from the top of the validator. Yep.
Yeah, validator. So we call our validator marketplace, and we're going to parameterize this validator with two things. The owner, which is an address, and I know address is a byte array, but just to see that comes from use Cardano address. And if we were to look at the docs, address is just a byte array, kind of like right here.
Yeah. Address is a byte array. Are you sure? No, it's not.
Jeez. You're right. It's a, what am I thinking of? That's sorry, my problem. I was thinking of a
The payment credential is a byte array,
yeah,
though.
that's what I was thinking of exactly. The address is it's a payment credential and the stake credential. Okay.
Which is optional, yes.
Okay, so we're just going to call it an address for right now. So the marketplace is getting an owner, which is an address, and it's getting a fee percentage basis point, which is an int. And if I was to guess right now, the owner of the marketplace, that's probably going to be the person that sends the asset to the validator and saying, like, I want to sell this. Kind of like listing an asset. Like, I'm going to list it on the marketplace. I'm going to have my owner there. And the fee percentage basis point. Well, I don't know what that is yet. So, but we know our marketplace gets parameterized with these two values. Meaning it gets created. Like these are initial values that really set up the marketplace.
So if I had to like speak about why these are in here, in my understanding is that so all these parameters, owner, fee percentage, datum, redeemer, input, and transaction, all these are available for us to validate with. These are parameters that are available in the body of the validator to validate with.
Yes. But what's the difference? Because this is important. There's a difference of these values and these values.
Correct. Correct.
So the way I understand it is these happen when you create the contract, when you deploy it, right? People often use that word, deploying contracts.
Correct.
That's when you put these values in, when you deploy the contract. And then once that contract is deployed and you're interacting with it, then you deal with all these.
Correct.
And so the result of that is inside of the body, you have both these and these inside the body.
Yeah.
Okay.
So these parameters that go inside of the validator are parameters that you need to enter when you are sending in the contract. But these parameters inside of the spend, they are given in when you are building the transaction.
Yeah. Yeah.
Okay.
Yeah, definitely. This is when you deploy. This is when you do the transaction.
Yes.
I love it. That's Jim for me.
Yeah. That's a good one, right? Because that's hard to understand at first, is where these are coming from, the result is nice and simple. I get to use them, right? In my body, I get to use all these things. But where they come from, how do you set them initially? It can be kind of confusing.
Yes.
But I think that is the best way to describe it. This happens from deploy. This happens during the transaction time.
Yes.
Love it.
Okay, so now we're at line 36, right? And we have all our parameters available. So let's start to use them, right? And remember that this is just returning true or false. So we're only looking for booleans. And it looks like if I close when redeemer is, so what this is saying here is we only have one operation on the validator. We can only spend. And if it's not spend, it's going to return false.
Yes. Script purpose. Yeah.
Yes, script purpose, exactly. I also I think of them as endpoints. Like if this was an API, this would be the endpoint.
Yes.
But script purpose is, I think, the correct term. Okay, so now we're into spend. So let's look into spend. We have the first check is expect some datum. So some datum, this could be either true or false. Like if this was none, like
it can't be some none. It has to be instead of some.
You would say instead of some, you would say none.
It would be yeah.
And okay,
and that would be like if
So
when would you expect none?
So so this line basically is just checking if the datum part is some or none, and also it is assigning a variable to that value.
That's the main thing, right? Is it's like I think of this as the primary action is like we're trying to get this variable datum, and we do that through this destructuring, but there's also this extra validation check because this is what we're doing. And this is Aiken, right? We are also checking something, right? Which is it's either some or none.
Yes,
But the primary reason we're doing that is to destructure this value.
correct.
Yeah.
So yeah, and you see that a ton. Like that little bit. Expect some datum equals whatever you've got your datum variable set. So
yeah,
or whatever your inputs, your parameters on your spend endpoint, if that's the right way to say that.
yeah. I think what you're trying to say, this is a very common thing to see.
Yeah, yeah.
We take
Yeah.
the datum and we destructure some value out of the sum. Okay.
Yeah.
So
There's a big advantage to putting it right at the top of the validator, because if this fails, we don't have to do all of this computation and then lose money,
Beautiful.
because if the transaction fails, we still have to pay money. So if it's the very first line, there's barely any extra money we have to pay, which is the collateral, by the way.
I actually don't understand this part because it will fail no matter what, and it won't and failed transactions don't cost money. It
No, they
fails
do cost
before
money. They absolutely
Yeah,
cost
Yeah.
money. That is why
yeah,
there
they
is
do.
collateral in Cardano.
Yeah.
Lewis, you
So,
you in on this?
yeah, I'm finally getting the gist of it now. So that line is just basically supposed to check if there's datum present, and if there's none, it just pulls out.
Yes. Yes.
Exactly.
Harsha, explain a little bit more because I think I have a misconception then
Yes.
on how this, like, when I thought it failed before. Just like all my testing, like it doesn't, it fails before it goes through, I thought.
So there are two levels of failing. One is like a basic level of failing which doesn't cost money, but once you enter the body of the validation, there is some failing. If it fails and it costs, say for example, you put the expect somewhere at the bottom, like somewhere below,
Yeah.
right? So that means some node somewhere is running this logic, and that means it is spending some compute,
Yeah.
right? So if someone sends a transaction that fails, that means they have like spent this compute, so they have to pay the money for that compute. And if you want to completely understand about collateral, I wrote other thing for collateral. Uh, you should read this.
Yes.
I'll share this.
What?
Yes.
Look at you go.
Uh-huh. Uh-huh.
Where do I share this?
The
Yeah,
dawn.
this has to do with the sort of collateral and that sort of this is what we do. This is Aiken.
Yeah.
I'm kind of curious about in our tests. And Harsha, are you pulling up?
What do you need me to pull up?
Well, no. Well, I thought you were pulling up something. I was going to vamp for you, but I'm curious about if we break it at like if we don't have a a datum option, like if we we create a failed test where there's no datum, would it in our tests like over in the terminal there, like the memory usage and the CPU usage, would that would go way down, right?
Yes, yes. Actually, let's try that because it'll clearly show here, I think. The memory usage,
Yes.
like these guys would change, I think.
Code Cow, are you willing to accept this challenge?
I already did it.
He did it. Oh, son of a
Well,
bitch.
I'm trying to. So I did get close test this one, and then I just did, I don't know, because I just did false instead of
So
validated.
this doesn't matter. So
Okay.
all that matters is where the first line is. Say, for example, this line
We need that to fail. That's what we're trying to
Yeah,
do.
so say for example, if we move this line to say, where are we using transaction inputs,
But
output
we also
address?
have to get it to fail without the datum,
Yes,
which
so
is
we are
Yeah.
using the datum here, right? So I can actually do that part. Oh shit, where is it?
What did you do?
Oh, nothing.
You're gonna paste
paste it
that expect some.
Yeah, expect some. So there are two redeemers here. Datum seller.
That's it.
Oh,
Where's
oh,
some?
I have to do it on top because like it's being used both in redeemer. So we
Yeah.
can actually do it twice here. Say for example,
Yeah,
I can put it here, and similarly in this also I can put it here, I think.
yeah,
Oh shit, where is this?
Is that right?
yeah,
I mean, I'm assuming we can put
Okay.
it twice. I just don't know. Yeah.
yeah.
Can
Those
you
run
try
at
it
different
now?
times. So yeah,
Okay. So you're running the tests.
See, 33,000, 32,000, and this one is see, to 20,000, 24,000.
So it went up.
It went up, yeah.
wait,
32,000.
how much? Okay, 32 to 32.
And this is 24 to 24, 20.
So it
Oh,
didn't
wait,
go
it
up.
didn't. Or is it the CPU usage? 83, 111,222. Oh, see, CPU usage changed 1114030. And this one went up to 11122,305.
Right, that went up. Okay, 83 versus 83.1. So that went up. Okay, so those all go up. 1114, 115. Yeah, so they all go up. Okay, the CPUs all went up.
Yeah, so I guess the memory doesn't go up
But which you also added, you took one line and you
and made
wrote
it
it twice.
twice.
Yeah,
Yeah, yeah.
so it's not exactly the same.
Yeah, that's also true. So I don't know how to like check this in this specific case.
Well, so unspent, I think that you were going down a different line. Let's
Yeah,
keep.
we need to fail it. We need to fail without the datum. So we actually trip that step, because I think what you want to do is we want to know how much data it costs to trip at that step
Yes,
versus if we put that step later down, then how much does that cost? But we need to actually trip
correct,
at that step. So I don't know how to,
correct.
we need to create the transaction without the datum and trip at that. I would put the expect back where it belongs, the
Okay.
Yeah.
one expect, and then let's move down to the test afterwards. Yeah, so go through that. Oh, it's because you're following me. I think it's like jumping like that.
Oh, like that. Okay.
Yeah, right. Yeah, it's I'm not even touching my
Unfollow.
phone.
So
There's
yeah,
a
if
pin
you.
button at the top that would unfollow me,
Oh no.
if that helps you.
Yeah, the pin. He has that green pin up there at the
Yeah,
top.
green pin at the top.
Yeah.
He's like, he don't want to touch it.
Yeah, it's up.
It's okay. He can do what he wants to. Okay.
Because I'm about to take over anyways.
Yeah, yeah.
And
Take
then-
over. Take
So
over.
I'll just take
yeah. Here we go.
Okay, so we have that there, and then we have our mock data. Okay, so maybe right. So this
Oh.
we need to pass in something that would fail there.
Yes. So this just has to be. How do you create a none thing?
I know.
We just
but
don't
it
pass the
could be
datum,
none.
then it'll be none.
Yeah, because if it is none, that would pass because we're expecting something.
Yeah.
Right?
So should this?
It's
How do
really
we?
fail,
Yeah.
like
So
yeah.
how do we pass a none? I have no idea.
I
Like
don't
just
know.
not pass it? No, but so
Yeah.
this is a
Ooh.
function. This is a function that takes two arguments. So it has to. Oh, so you can just put none here then.
I was about to say that.
Yeah.
That's gonna pass. That because our expect sum will pass with none.
No, expect some
Will
won't
it?
pass. Expect some definitely means not none.
If datum is none, this will work.
No, it won't work.
Ooh.
It won't
Oh.
work.
Yes, that we've a clear A/B test. Here we go. Okay, he's over in the terminal. He's running the tests. We've changed it from mock datum unknown. Did you? No, I think he took out.
Where'd it go? I don't know. Something happened there.
It's
We lost our.
hit undo a couple times. Oh, yeah. There it was. Yeah. Everything passed.
Like I thought.
So, yes. Not expect some means it's either none or something.
No. I still
Yeah, let's go.
disagree with it.
Let's check the docs. Check the docs.
No, but
Go back to
expect some literally that line literally means expect some, not none, is what it means.
I disagree.
How do we
yeah.
try
Go to
this?
the docs.
How do we try this?
Docs.
How do we try this? I feel like we should be able to try this.
I'm looking at the docs.
Like I passed it none and get closed TF, right? And it worked. I passed it none instead of mock datum, and it succeeded.
Yep.
No,
true.
but line datum.
Oh, this is closed test. Okay, hold on. Maybe you're right. Let's continue on. I think it needs to be here. I think
instead of some, just put none and see.
Yes, and I think okay, maybe this is
might
gonna
be right.
fail. Maybe this is gonna fail unless we do some none. But let's see. Okay, this is good.
So it failed. One test failed.
Where you thought it, because I just passed none here. So if I did some of none.
Not sum of none. Sum of none doesn't exist. Sum of x, put x, because none is a type. Sum of x. Yeah.
It's gotta be like a string though, right?
No, it can just be so what was it previously? Somewhat? Like I feel like this is very specific to something. Yeah, some mock datum. Yeah, that's fine. Yeah.
Okay, so I think Harsh is right and I was wrong. Because if we just pass it none, that is not this, right?
Yes.
Okay, so what I was doing here, this is on the close, right? This is really important. I was closing.
But close also has a datum, right? See datum.seller. Address pub key. Oh, okay. So, okay.
I don't know why this works with none.
Yeah, I don't understand why it works with none. Oh, maybe it's because address. Oh, now I get it. So if it is none, address.seller becomes empty. Like what happens here if it's none? Because I think it has to do with that function. I think it has to do with, oh shit, where is it? I think it has to do with address pub key function. Address pub key. Let's see. Address pub key is a mocktail, or maybe address pub. No, so it maybe
it's a cocktail.
So address pub key is a function that takes an address. But if the address is none, address pub key takes an, oh, it gives an option of verification. Oh, so, oh, this is the one we needed. Okay. So it gives an option of some, oh, so this can be none.
Yeah.
Address pub key can be none, but like it still needs the address, right? If we pass in none in the datum, I don't know what value is being passed into this function actually. Does it make sense what I'm saying?
Yeah, I mean, I'm confused why this line doesn't break it.
Yeah. So again, this line in the close, it is closed, right? That line is related to this line in the close. So that means this datum dot seller, some value is being passed and it is passing. I just
So
don't understand. Yeah.
Oh, yes. Let's use a trace. Beautiful.
I haven't written this in a minute. Is this it?
Yes. Is that how? Yeah, I think so. Yeah.
Yes.
Yeah. Actually, try that. I want to see. I want to see how it works.
Mm,
What was the error?
yeah, it's not.
The
That's not right.
close. How do we use traces? I'm gonna quickly check
Yeah,
traces.
that's a good important thing. So I've got, yeah, just to try it. Yeah, yeah.
Traces. So you say at is even. Trace at. Oh, we didn't put an at, did we? Yeah. So there should be an at.
Oh, yeah, there you go. I bet that works. Do we need the brackets? Yeah.
On is it?
Hmm.
Wait, I think the at comes after. Yeah. See trace at. So, but this just traces. So this is just like a
Here it is.
string. So what if we had to pass a variable here?
I got it.
Oh, you got it? Okay.
Scroll down on the terminal.
Oh, you got it. Okay. Let's see. What is it saying? Datum
What?
seller. What the fuck is this?
121 is it's either true or false. Like it's either 121 or 122. Those are Aiken things. So, but I think
What?
because we're actually getting some values, I would right. You see 122 later in it, and
Yeah.
122 is empty. Yeah. So those are like
Yes.
I'm not really sure. One of them is true. One of them is false. But I like if that was empty, we shouldn't get anything. I would think.
Interesting.
So get close. Right, because what tests are we even doing? We're doing get closed test case, which oh, I know why. We're so dumb. I'm so dumb. Okay.
What?
What happened?
No,
What
no,
happened?
no.
Tell us.
Okay, get closed test case is here. It's getting called right here
Uh-huh.
because it's part of the you have to spend it. You have to spend it's all one thing. So you're spending with Datum. So this is why it's passed there because we're spending with
So
Datum.
this has to be none then.
Yeah, what I'm saying is, so this datum right here,
Oh,
TX inline
oh,
datum needs to match this. They should match. They should match, and they're not, and that's weird to me. But what I know is why is this getting its datum? Because it's actually coming from
Here.
right. Yeah,
Yes.
we did it. We did it in the get closed test function and not in the test itself. Yeah.
Okay.
so yeah, because they need to be called together. Okay.
Yeah.
Right, you in this fail spend, right? We also do the get closed test, and look, oh, then we have a buy test case, and then we have a spend. So okay,
Yeah, and it might be worth because this is when I looked over the marketplace Aiken file. I it does take a little bit because there are these functions before the tests that basically like there's that on 84 that creates some mock datum on 93 that creates a transaction for it's as if somebody is making a closing transaction and it goes through all the mocktail stuff, a big chaining of mocktail things. and then the tests are created. So it's kind of like the structure, the big overall structure of Marketplace is important to understand.
The green words, or I guess they're purple on your screen. These words are your are going to help you differentiate.
Yeah,
and
yeah,
it's
yeah.
tough to see it at first. You know, minimizing them is really helpful.
Minimize.
Because
Just
Yeah, just like
yeah,
this, right? Like this.
yeah, man, yeah.
it just does that on my screen when I minimize. That's like a local thing.
So
But yeah, so if you minimize those, and then you can easily see your types, your functions, and your tests.
Yes, yes.
Because that, right, the get by test case is kind of like lost in there. It's a function that's like lost in
right.
between the types and the tests, and they're like, right, we just like kind of breezed over that, and we kind of got into that bug of not understanding that, like, oh, this isn't a test, this is a function which gets run as part of a test. Right.
Yes.
And it would have been easy if we could have known that by just looking a little bit harder. But yeah,
This I like that as a pattern. Like if you want to understand the code base, and it can be really difficult, but you can do this little thing, which is minimize and close everything down so that you see, it's like zooming out, so you don't look at this giant thing. My eyes start to swim. I'm like, it's easy to get confused. It's easy to get lost. And this is one way to not get lost. Yeah, perfect.
All right, but are we clear with the none part? I still think this one expects some, only passes when there is some and not none.
So, yes. Now, did we get to verifying that? Because we know we can look at the documentation, but it's cool to check it, right?
So the two places that we're using the datum is here for the close.
Yeah. Mm-hmm.
Close test case, yeah.
Yeah. So if we change both of them to none, it should fail.
And then do I put some none or just none?
No, there's no some none. There's only none or some.
Yeah.
You can see where I'm confused.
So, but what we could do is create another test so that we don't have to, because now you want to say us, or just change that name to fail spend marketplace close.
I think this should
on
work. Like,
109.
that'll be like a couple of extra steps. So this should basically fail all the tests.
Oh, did you already did that? Oh, you did it?
Yeah.
There's an error. There's a fail. That's it.
Okay, successful marketplace. So what I did was I did none here and I did none here. So this is okay. We need to come full circle. I know it's taken a long time, but we need to come full circle to the question of the computational cost, because now we have tripped the expect sum datum equals datum opt. So now what we want to do is we want to move this, correct?
But we'll have to move it twice anyway, so it's hard to like figure it out anyway.
Well,
I think the memory is I think that's what will change. Actually, I don't know.
No. It's a CPU that has to. I don't know, actually.
Yeah. Right. Well, let's just. I mean, we can go this way, so let's just see. I'm gonna copy all of these down.
Here, get all that set, because I feel like you've already done it, because if you scroll up to one of those that first test passing, look at the memory use. And then
see, the memory
scroll
went up.
down.
CPU went up.
Well, do the first test where it fails.
Okay, so this was the test. This was the normal one. Okay, this was when it was at the top.
Yes.
And then I just moved it, so now we doubled it, so we have more text there. But we did that check lower down, and so what we're trying to see is this now a more expensive transaction?
Yeah.
Correct.
Okay, so what I see is CPU is not changed.
for the
Oh,
first one,
no.
no?
CPU went up by 8.
Oh, you're right. You're right. Yeah.
Okay, and then 680. This is 681. So CPU went up for all of them. Maybe even a consistent amount.
Yes.
Right.
Yes, you're right.
Right, that kind of seems consistent, but I'm not great
Even
at
the
that.
memory went up. Even the memory
And
went up.
the memory went up, which it didn't do last time, remember?
I mean, or maybe I was looking at it wrong. I don't know.
Okay, so I think the memory is what would go up for this execution cost. But I'm not sure I could explain why I think that, and it could be wrong. But I guess I'm okay with this. This is what I wanted to figure. Is right. The question was, what happened? Like, when do you want to fail things, and why do you want to fail things in different places? Like, why do
Yes.
you want to fail things early? And the question really was like, how do we save money? And
Yeah.
then you get to, well, what's costing more money, right? Like, how do you actually make it?
So the costing part, I think the fail test. Oh shit! I'm gonna stop following you for just 2 seconds. How do I stop following
It's
you?
the green pin at the top.
The
Green, this
pin
one.
right there. Yeah.
Oh, I
Yeah.
see. Okay. So the failing tests are still costing money, right? In a real-time transaction, this
Oh.
transaction fails, but it still costed this much.
Yeah.
And someone has to pay that money. That money goes from our collateral, that the 5 ADA UTXO or whatever we lock. That money goes from
Yeah.
there for
And
these guys.
in our change, we made it more expensive. In this edge case where somebody's failing, we have just made it more expensive
Right.
by doing that change. And another way to say it is, originally we had made it efficient.
Yes. Yes. Specifically for the failing test, because if it's, I mean, passing also,
Yeah.
it costs more money, but if you fail, now you didn't send the transaction and still paid more money.
Yeah, exactly.
Yeah, cool. I get it. Oof.
I know.
I love it though, man.
I'm
I
gonna
love it.
go. Okay, unspent. I'm following again. So, okay, so where are we at? I think that was the first line of the validator, by the way. We got through the first line.
I really
Yes.
do, guys. This is literally like, I mean, at this point, it's a pattern of like, how many minutes can we take to go through the littlest lines of code?
But I learned
Yeah.
so much, so I'm not worried about it.
I'm not worried
Yeah.
either. I feel like this
No.
is our task, right? Is to just take it wherever it goes.
And one thing that happens, and one thing that happens is that we turn around in a circle and we rediscover things. I think in one of the first, maybe it was a couple weeks ago, and it's like Unspent was like, we just proved the rule, like we just figured something out on our own, and it wasn't told to us, and we didn't read it and accept it, like we really like hashed it out, and among the people here, like, because everybody's like, no, I have this idea. And I love like when there's a disagreement, or like, I think it'll work this way, or I'll think it'll work this way. And then it's sort of empiricism. That's a fancy way of saying like, we just test things out, you know? And I think it's one of the great things about programming, and especially with this Aiken and the testing right in there, which is beautiful, which is really beautiful. So I think it's working. I think it's working.
I think so
Yeah.
too.
Eventually, we'll be a more oiled machine and like move through these things. And so
Much
if you're
faster.
watching this now, like just I think the people that are watching, if you're at this point in the video, I mean, it's like you want this kind of stuff. You also have these questions, and you don't know how to figure them out, and you just need to brainstorm with other people,
Yeah.
right?
Or they're like pulling their hair out, and they're like, oh, just turn around and look at the road. You're almost on the road. They missed it. Oh no, we should have said that. I could see that. If you're watching this on YouTube, hey, why don't you leave us a comment and tell us how you're using it. But no pressure, no pressure. That is wonderful. So, a little bit of housekeeping. We have been we wanted to extend a little bit of time. So we're at the normal sort of stop time, but we started a little late. We started about 15 minutes late. So do we want to go for another 15 minutes? Do you want to try the next line?
Yeah. I
Yeah.
guess that's all we'll get through anyway. So yeah, one line.
Why not?
Lewis is down. Lewis is down. Thank you. All
Let's
right.
go.
Let's see what we get.
Okay.
38.
We're at line
Yeah.
30. Okay, cool. So, right, we've got our datum. Okay. And now when redeemer is. Okay, so this is great because our redeemer can be two constructors, right? It could either be buy or it can be close, and neither of those are taking parameters. But we have to know which one's which. This is like our ternary operator. Is it this or that? Okay, so when redeemer is buy and when redeemer is close.
Yes.
So yeah, so we think of these as completely two separate things, right? Like this is one instance, and it will, if you're in buy, you're never going to be in close, right? So let's just think of them one at a time. So when redeemer is buy, we're on line 40 now.
Mhm.
So this is our destructuring pattern where we expect some, and then this is going to be our variable that we're pulling out and destructuring from find input tx.inputs with input. Okay, so find input is going to be one of our vodka.
No, find input is in Aiken. Let me pull that.
Ah, you're right. Yes, okay, good. Yeah, let's look at this. So we're passing in our tx.inputs, which is a list of inputs. And then we're also passing in a singular input, which is an output reference.
And it
So-
is of the type option, so it can be none or some, and that is why
we're
we
looking at
specified.
Sorry, you were looking at the code for find, and we need find input.
Oh, so find input is different. Okay, so
Oh,
maybe
It's
that
still
could be
Aiken.
mocktail.
No, it's still Aiken. Yep.
okay. Find input. Oh,
There's-
it's in transaction. So what does this do?
Right, so like I
Find.
said, I'm passing a tx.inputs, which is a list of inputs, and then I'm also passing a singular input, which is my output reference.
Yes. So you're not passing a singular input, you're just passing the output reference because the output reference is a part of the input.
Yeah, it's how we label it. But we are passing the output
Oh,
reference, right? We just call it input.
input.
Yeah,
It's of a
so
type output reference. Yeah.
so no,
Yeah.
input is defined like this, which is made of like the output reference. It has two fields, output reference and output. So we are just passing the output reference field and trying to find the correct input in this case.
Yeah, but if you go back to our code really quick, because it's just semantics. We on line 33, we call our output reference input.
Oh, okay.
So that's it. Because this is our function right here that we just looked at the doc. So we're passing our tx.inputs, our list of inputs, and then we're passing our output reference.
Correct. Yes. Yes.
Okay, and just really quick, can we jump in and see, because this find input is going to return probably an option of an option of an input. Yeah, exactly. So that makes sense, right? We can read that there. It returns an option of an input, and so on line 40 we can expect some of an input.
Yep.
Cool.
Yes. Yes.
And so what this actually is, own input, when you use the output reference, is the UTXO that is being spent. Own input it's just a variable name that we use, but it's an important one because it is the UTXO in question. There could be many hundreds of UTXOs at the marketplace, and when you interact with them, you could spend multiple of them in one transaction. But in terms of the validator, it works one at a time. The validator runs for every single UTXO. So what UTXO are we talking about? Own input. That's what we're talking about. This is the one that we're talking about. It's own input.
Okay.
Maybe that doesn't make sense, but it is an important concept. Harsh or Newman, could you try to repeat that in your own words?
Yes, yes. So what did throw me off is the word own input. So in this case, when we say own, we are referring to the validator's own input, I'm assuming, and not the input from the user.
It's
Yeah, because the spend in the spend, there is always a UTXO, right? Like the input is output reference. So this is always the UTXO being spent from the validator, this part.
so maybe this, hopefully this doesn't confuse people, but it's transaction.
Okay.
Okay, so what I'm saying here is the validator has multiple UTXOs locked in it.
Mhm.
And when we create a transaction, we want to spend two UTXOs. We want to spend both of the UTXOs. During the runtime validation, when the marketplace is actually validating, it does these independently. This one goes through the validation script as own input. And then when that's done, this UTXO goes through the validation script as own input. So if my transaction is trying to spend two UTXOs that are locked at the validator, I have to run each UTXO through the validation.
Correct.
And when you run through, this UTXO becomes this input. So we know when we're here, we're not dealing with this UTXO, right? We don't care that the transaction has multiple of these UTXOs because we're thinking of it as an individual level. We're just dealing with this own input.
Yes.
Yeah. So I hope that doesn't confuse you.
Yeah. And
Yeah.
this own input from the validator is always listed in the spend part. It's not listed in the marketplace. It is always listed in the spend part. So this always is the input from the validator.
Yeah, that's actually being spent.
Yes.
Okay, so cool. So we have our own input, and like we said, that's really important. We use that from the transaction.inputs and our output reference. Now we have the UTXO that we're actually spending. That's part of the transaction, and that UTXO has an output.address, and so we can call that our own address.
Yeah. So by the end of the day, it's just the validator address that we are finding here.
Because yeah, it's interesting. It is, yes, it is the validator address because this UTXO is at the address.
Right.
So you're actually finding the address of the UTXO, but because that UTXO is at the validator, at the marketplace, then you're also finding the marketplace address.
Yeah.
Cool. Okay. So we have our own address, which is our marketplace address, or the UTXO where it lives. It's both of those things. So let is only one input from own address. So this is interesting. So the own address we could consider as the marketplace validator address. So when inputs at the validator is a list of 1, it can be true. And if it's not a list of 1, then we're going to return false. So this is the catch-all, right? And what we're saying here is like if we wanted this to be like something specific, we could call it that.
Okay.
Oh yeah, not camel case. But we don't care what it is. We only care that it's 1, that it's a length of 1. And if we wanted a length of 2, we could do like that. And this would be saying when inputs at our own address is length of 2, we would return true. But So those are just different ways we could do it. But right, all we're saying now is we just care its length of 1, and we don't care what it is. We just, when it is one address, one input at the validator address, then we return true.
Yeah.
Yeah.
Otherwise, false. Okay. So if you try to do this with 2, if there's 2 inputs here, it's going to return false. You're not going to be able to spend it.
Yeah. So basically, this with this line, all they are saying is you only get to exchange one NFT or whatever at one time. You can't do like 2 NFTs at the same time in one transaction.
It is only one input from own address. Yep.
Yeah.
All right, cool. So let's say that's true. So we only, well, actually, it doesn't even matter because it won't fail. We're right now, these 3 steps build our variables, and then this is where we actually run our validation. This is the Boolean check on line 58. So right now we're still just building our variables. And to come full circle, if this were to fail right here, oops. If this were to fail right here, we're still gonna run this, and we're gonna run this, okay? Because we only checked that validation here, which is interesting because maybe it would be better to write those here.
No, you can't do that. Remember, we did this like previously. There cannot be like a unassigned tool in between a body.
Right. It can only be one. Yeah. Yep. Okay. So anyways, I guess we're just stuck running through all of these validations, right?
Yeah.
So yeah, on line 48, we'll do the next one, which is process paid. Okay. And I can see this is a function, get all value 2. And if we could guess, that's probably a vodka function. And yes, it is. It's a cocktail.get all value 2. Harsha, you want to pop us over there?
Yes, get all value 2.
Get underscore all value 2.
It's a vodka.
Yep.
Pull that up.
Okay. So I am passing it a tx.outputs, which is a list of outputs, and I am passing it a datum.seller, which is a type of address. So I'm passing it a list of outputs and an address. And that's what that says.
And it gives out the value inside of that address.
Interesting.
So not inside of the address. This is the value that we intend to send to this address. And if you want to see what this means, all we need to do is go to the output. And in the output, you see the address and the value. So they're taking this output object, they're checking for the address, and they're giving out the value that is going to this address.
And they're probably reducing it because you take a list of outputs. So then you just like map over them. You if address is address, then like add the value to our.
No, I don't think they're reducing it. Like,
or sorry, I use reduce as like I think of JavaScript always, and that's a function where you're like you reduce an object and you basically build it over time as you map over it.
No, so in the outputs, there cannot be 2 outputs to the. Can there be 2? No, there cannot be 2 outputs to the same address, by the way.
Well, I don't know about that, but I don't think that's our question right now. Go back to the code really quick.
Yeah.
Because this is, we're on line 48. Get all value 2. It's adding all the values. So it like maps over all of the outputs. And like you said, it checks.
So you cannot add values because value is a very specific kind of type. Say, for example, value, right?
But get all value 2 is literally adding the values.
So that's what I'm saying. You cannot add the values because value is in itself like constructed with a policy ID and asset name. So you just cannot like add it like integers.
But you can. That's what the function is doing for us. They're helping us add.
Yeah.
No, I don't think it's helping us add, by the way. I think it is just giving us the value. So it'll be something like, actually, let me show you mesh because I'll show you.
Well, hold on one second, because maybe this could just be semantics. Because if I have two outputs going to datum.seller and the first one has 5 ADA value, which I know is the object of like Lovelace and then the 5.
Mhm.
And
Okay, but then
policy ID
also,
and assets. So because there could also be assets in it.
okay, but also I'm also doing another one because there's two outputs that are both going to the datum.seller. The function get all value to is aggregating or adding all of those values from the outputs going to the seller. So the result of the get all value to is the addition of all the values. Does that make sense? Get all value to.
So are you only referring to this line here?
Yes.
Yeah.
So I am still not like in line with that, like adding part. It's just literally getting like this value
If,
object from it, and it's not
and if you have
what is
two,
being added. What is being added? I need to understand. Yeah.
really
Right.
close. Okay. If you have two outputs with their
Uh-huh.
own values,
Uh-huh.
what how do you get all how do you, to you what is get all value, like what is the result of that? It's
A value. Result of
one
that is a
value that
value.
is an addition of the two values of the outputs, right?
No, it's not. That's where I disagree.
Yeah, so and this is important because I don't understand why you disagree, but I know you're smart, and so I'm just missing something. So
Okay, so when you say adding values, so the value will be like, say there is some ADA doesn't have a policy ID, so policy ID will be blank, and amount will be 5 ADA in one value. Okay.
yeah,
And there will also be other sections because there could be other assets there. Like say policy ID for some random token is X and the value is 10,000. And in the other one, there will be ADA and some other random token. So you cannot like just add values.
I agree with that. They're
That's
different
agreed.
things. What you could add is the same policy IDs together. Like you could add Lovelace together with that. But this function, like the return of this function is really where I'm talking about, because this function does return us something, and it
A
is
value.
either the addition, like I'm talking about, or it's not. It's some list of objects that are still separated, and
It
maybe
is
even
so the reason I say this is it cannot be a list. It only gives one value because in the
Yeah.
outputs to a specific address, there will only be one output object that is going to a specific address. There will not be multiple output objects going to the same address.
yeah, you could totally do that.
Are you sure about that? Because I feel like that's not
Oh.
possible. So
I'm trying to think. Maybe I haven't actually done that. Two outputs.
going to the same address, I don't know if it's possible.
Yeah,
How do you figure
yes,
this
I
out?
do that. I do that. I've done that. I'm 95%
Can you like
sure.
quickly show how that?
Oh, it's in double spent. Right, because let me look.
Yeah, take some time to track it
So
down.
in my head, like the reason I say there cannot be multiple outputs to the same address is because just think of it like this, right? The address will be the same, right? And the value is what will change. Say, for example, there are two separate assets or four separate assets going to this address. All of those
Okay.
assets will come together into the same value.
Yeah,
So you don't need to send two outputs to the same address.
yeah, I think you could be right. Is it possible to craft the transaction though, to where you just explicitly send two outputs to the same address? And like, what would happen there? Is it going to combine those for you into one output? Or if you say that, if you make your transaction with the two
Actually,
things,
yeah, maybe you can like craft like outputs that go to the same address, but you'll have to craft the value and the datum and all of that. So assuming we can send values to this same address. So again, my point of contention is that you cannot add the values.
So, okay.
Oh, okay. Yeah.
What does get all value to return? Because I'm not trying to contend with that statement. I am trying to make sense of what this is returning. Because to me,
Yeah.
this is returning the additional value, right? So that's all I'm trying to figure out right now. Can we maybe look at the docs again and what
Yes.
get all value to returning? Contains the
all value
value
to.
sent to a particular address in a list of outputs. And the type of value, let's look at that again.
Look at what again?
Yeah, look at value, like what it returns. We're returning a value. So let's look at value.
Value is something like this.
A multi-asset output value contains tokens indexed by policy ID and asset name. Important. This type maintains some invariance by construction. In particular, a value will never contain a zero quantity of a particular token.
But the multi-asset output is important. And so I think, right, the value, one object of value could contain Lovelace of 5 and then NFT of 1. And that is all one value because it's a multi-asset output.
Correct.
Okay, so what happens if you have that in one output, and then you have another output with another value, and both of these outputs are going to the same address? And now we have our function, get all value to, which returns a single value object with multi-asset outputs in it. So what does that singular value look like at the end? Is there only one part where it's Lovelace and it's the addition? So like if it was 5 and 5, the new one would be 10.
So in general, I have a question for you, Unspent. Can two objects be added?
However right. You could just take the value and then manipulate it and then create a new object. You could do whatever you want, I think. Right. And so that's normally what these functions do. It'd be nice if we could see the source code for get all value to. And
go for it. Go back to that one because it uses the fold R, and I took a peek at it, so you might get some.
No, for Fordle, yeah.
That's the JavaScript reduce, which is going to be adding the things.
Yeah. Oh, it does use the Fordle R.
Go back to, you had it in another tab. You were in another tab. Go to your tab to okay.
Like what Fordle R dictionary?
Well, no, go. Okay.
Get all value to from vodka.
Yeah.
Oh,
go back to your vodka thing.
And where do I check?
And now, right there. See how it's
list, folder, output, accumulate value, merge, accumulate. Oh, I think Unspent is right? Because it looks like it.
Yeah.
So you can add values together. Okay, I didn't know you could add. Well, you live and you learn.
I love it.
You're not wrong at all. I think we're just like whatever. You're right there. You're just like off to the side a little bit because none of what you said is wrong. Like the value is one object and it's multi-asset, and so what I think is happening is if they are the same type of value, whereas if they're the same policy ID or they're the same Lovelace, then those get combined or added into a singular function. Yeah. So and again, it's all one value, but there's multi-assets within that value. So now we're talking about these multi-assets in themselves. So like if you have two outputs, each with ADA in them, it's gonna combine those ADA as the Lovelace part of the value object.
Now I
And
get
if you
it.
had NFTs in your value and those NFTs were the same policy, then when you ran the get all value to, it's going to put
Okay.
those into one.
Okay,
That's how
I'm just gonna write it here just to like give a small example. Say there is a value here which is constructed. Oh shit, where am I writing this? I'm gonna unfollow for 1 second.
Thank you.
So say for example, policy for ADA is just blank, which would be this, and amount is say 5.
Mhm.
Wait, this 1 second. And there is another token, say X. So the policy is some X. I'm just going to put X, and amount is 2, right?
Yeah.
And then there is. Why is this being weird? I close this. I close. Oh, there's an extra one. Okay. So
Yeah.
there is another one, which is. Which is say 10 ADA and policy Y. Actually,
Okay.
let's do policy X also, one policy X.
No. Do Y to show the difference.
And no, I'll do another Y as well.
Okay.
I think I know where you're going with this.
Yeah. So I'll do policy is Y and amount is 1. So when you are adding both these values, the final value will be like this, which is I'll have all these guys.
You'll have, every type.
But it'll be the sum of, say, for example, ADA is first one, ADA is 5, and the second one, ADA is 10. So this will be 15 ADA. And here there'll be X is how many? 5X and 2X. So this will be 7. And policy of Y will be 1 because there's only one. So this is what the final addition of values would look like, correct?
Yeah, just remove the 115 just for accuracy.
Oh shit.
But yeah, that's it. That's how I understand it. That's that function of get all value to. And really what it's important to note, that's using the folder, because all of the vodka functions are just helpers that use the Aiken library. And what's really happening is the folder, or however you guys pronounce that, right? But that is that way to kind of map over and build an object through.
Yeah, that makes sense. Okay, well, better
there's
to
a lot
make
of-
all the mistakes now rather than when you're writing a validator and then you get screwed in real time.
Yeah. So that get all value too. It's a really good function. I just feel like it's worth all the time it takes to understand that function, because I don't know. It seems so fundamental to what we're doing. So yeah, I think so. We got to line 49.
Yes.
And we got all. And so what this is going to return a value, which we know what that is, and then
total
we're going
value to like a specific address, all the values.
All the values,
combined value object, and
combined value object to the Datum seller, and we're going to pipe that in to value dot or value is greater than or equal to. So Harsha or Newman, could you explain quickly how you think of the pipe operator right here? When we have this value returned, and now we're going to pipe it here. What are we doing?
So instead of pipe, I just use the word pass. So you get a value and you pass it into this function, which is value get. And that will become the first argument. So you don't actually have to write the first argument here. You just pass the second argument.
Right. So it's like, this is going, it's almost like this.
Yes, exactly.
Right. Where this is getting this is the first argument.
Oh, yeah, sure.
Okay, cool. So So yeah, value dot greater than or equal to is getting our combined value, and so it's right. Combined value is greater than or equal to
I think it'll
this
be a good
value.
idea to check value gec.
Yeah, because it's going to take two parameters,
Yeah.
basically two, the greater
So
and the
it
smaller.
takes
Okay.
the first value, the second value, and it gives a bool. Check if the first value provided is greater than or equal to the second value. Okay. So in
Cool.
this case, we are saying this value that we get here, the combined value that we get from here is either greater than or equal to this. If it is true, then it gives false. Oh, sorry, it gives true. But no, if not, it gives false.
Cool. So we need to make sure our value going to the seller is greater than this.
Right.
And so what is this? Okay, from Lovelace is probably just the math function. So let's do datum.price plus Lovelace of, another function, of own input. We know that. That's our UTXO that's being spent. Oh, and that's the value. Okay, so the UTXO being spent has a value, whatever that is. It was already locked there. And we are going to get the price plus that value.
Yeah, just addition, straight up addition.
Why?
Looks like.
Why are we getting the price plus that value?
So I'm going to quickly look at datum.price. So marketplace datum has a price in it. So that means the price is ADA. My guess is it's an ADA. So you're able to add both of these guys. Because Lovelace off also gives like an integer. Let me check Lovelace off.
Oh, I know why.
What is it?
I know why. Okay. So what it's really saying is this. This is the core logic.
Okay.
Okay, is all the value going to the seller greater than the price? Because when I go to the store and the price is $5, I have to give them at least $5, right? Because the price, I have to be greater or equal to the price. And if I'm greater, then it's going to give me change, but I can't be less than the price. And so that's like if we were going to a store. But because this is the blockchain, the own input that's actually being spent has value locked into it because you has to. Like the minimum ADA is like, let's say it's 2, or maybe it's 1, but let's say it's 2 ADA locked at the UTXO here. So the price of the marketplace item is the price that they put in the datum plus what's already locked there.
Oh, locked in that specific UTXO. Okay.
Because otherwise, if you were to just do this, it's going to cost, 2 ADA to lock the value here. And then if you were to sell it for 10, you're like, okay, I'm going to sell it for 10. But what they're buying for 10 is this marketplace item plus my 2 ADA that's locked in it. So
Correct.
they're actually only buying it for 8.
No, 12, right? Oh, yeah, they're buying it for 8, but they have to pay 12 because they're also paying back the 2 extra ADA stuck there.
You would, I guess, in this situation, if they were to just do this right here, they would be buying it for 8.
Yes, that's right.
Even though I put the price as 10, because, well, the thing is, yeah, they would be buying it for 10. Sorry, they would be buying it for the price, which is 10.
Correct.
But what they're buying is that asset that also has value in it.
Correct.
And so that's why we do this, because this is the total of the price plus the value that's actually already locked at it. So yeah, so that makes sense. That's kind of like what is happening, is, yeah, we're just, that's the total amount. Kind of confusing, but it does make sense to me. Does it make sense to you guys?
What you explained made perfect sense to me. Why are you confused now? I'm curious.
I'm good. It makes sense to me as long as you guys are too.
Yeah, it
Yeah,
makes
I
sense to
mean,
me. Like, how about
yeah,
you, Newman and Lewis? How are you guys feeling about this?
it's interesting because I understand it enough, I think, in order to sort of like cruise through the woods. Now, I could inspect the tree, to use this analogy. I could inspect the tree and be
So,
like, oh, wait a minute, right. Yeah,
I can just like write it here. Say there is a UTXO locked in the marketplace.
yeah,
Okay. This UTXO has an NFT and it has some minimum ADA value or whatever ADA value locked
Yeah,
in
because
that
it needs to.
UTXO. The price listed is say 8 ADA. Okay.
mhm.
Now, if there is a seller, if there's a buyer,
Oh, yeah, I got you.
they need to buy it at a price that is 8 ADA plus this NFT
Plus,
cost. The price is 8 ADA, right? So the buyer has to, the value coming out of the buyer's pocket has to be, uh, just say 2 ADA locked here, so it'll be easier.
yeah,
So the price coming from the buyer has to be 10 ADA.
Yeah.
By the end of the day, they're still buying it for 8 ADA because this 2 ADA that is locked in this UTXO goes back to the buyer. So by the end of the
yep,
day, the
yep.
price remains 8. Does that make
And
sense?
then, yeah, and the new, like the purchaser has their NFT that still has 2 ADA locked at
Yes.
the NFT. Right? Because when they buy it, they get that NFT and it's locked data. And so they're basically paying the seller that locked data to do that clean switch.
Yeah, and they'll get the back that ADA anyway.
It's no, because that ADA is locked. They don't get it back. It is part of the UTXO with the NFT.
Here's the NFT.
Exactly, but to get that NFT, you'll have to spend that UTXO.
Yep.
Ooh,
So they
yeah.
will be getting back the 2 ADA.
So technically, it comes back in the new UTXO. Is that what you're saying?
Yeah.
It doesn't, but it's not that. It's new 2 ADA because the 2 ADA that is at the NFT is spent, okay, and that goes to the buyer. And so the buyer now has an NFT with the locked ADA, the 2 ADA locked.
Yeah.
Okay.
So there are 2 new UTXOs. Say this is the initial UTXO, which has a UTXO plus 2 ADA, and the price is 8 ADA. So now the buyer sends 10 ADA, and there are new UTXOs created where seller gets a UTXO which is worth 8 ADA.
Not 10.
No, it'll be 8 ADA.
No, it's 10.
Oh,
So I think there's a small confusion here. The thing is, the buyer is sending a UTXO that this is an input, right? This is
Yep.
an input.
It's an output.
No, the buyer is sending an input of 10 ADA. It cannot be like the output.
Oh yeah, sorry. Yeah. The buyer is paying 10 ADA input. Yep.
Yeah,
And that
and the
creates a
seller
UTXO
is
for the
getting
seller.
8 ADA, and the buyer.
No, because look at the line of the code. It's the get all value to the datum.seller is datum price plus Lovelace of own input dot value. So it's getting 10.
well,
So
that's
so the buyer, all this is saying, in my opinion, is that the buyer is paying 10 ADA. Yes, the buyer is paying, like the input UTXO has 10 ADA, but like the output UTXO will still have the NFT plus 2 ADA.
Yep.
You know what I'm saying? So the
Yeah,
buyer will get back the 2 ADA and the seller will get the 8 ADA. The check that we are doing right here is just to make sure that the buyer is actually sending 10 ADA and not just 8 ADA. Otherwise, he's buying the thing for just 6 ADA, remember?
Yes, but the seller is getting 10 ADA. This is where we're confused. You still think the seller is getting 8 ADA, but it's clearly getting both of those. Right? datum.price plus the own input value. That's what the seller needs to get.
No,
So
so
seller,
this is just a comparison operation, right? This is saying
Yeah, I feel
this is
like that.
saying
Yeah.
it's not the sending operation. This is just comparing. This is just saying, hey,
Yeah.
is 10 equal to 8 plus 2 or greater than or equal to 8 plus 2 is all it is saying. It's not sending yet.
yes, it is, because it's tx.outputs.
Tx.outputs.
Let's see. Let's see.
Get all value to tx.outputs. So
Mhm.
the outputs going to the seller. That is the outputs.
Oh, maybe.
Oh,
It's
you're
not the
right.
sending
You're right.
function.
So, oh, you're right. You're right. This has to go to the seller. Correct. This has to go to the seller because the seller is the one who logged that ADA.
Yeah,
So the
yeah,
seller has to get it back, and the
yeah.
buyer only needs to.
Perfect.
So instead of
Wait
this,
a minute. Wait a
it
minute.
is 10 ADA going to the seller. Write this how I'm saying it. It's 10 ADA going to the seller. It's not 8 plus 2. It's 10. Can you write that?
Yes.
Yeah. Okay.
Oh, so you know what? I
Then
think 2
that
ADA
gets plus
still
2.
comes
Yes.
back to the buyer.
Because it's on the like that is one UTXO. The UTXO
Correct.
has an
Correct.
NFT and it has 2 ADA locked. So then, and the seller just removed the plus 2 ADA. Yeah.
Yeah. Yes. Yes.
And
Correct.
that's
Correct.
what's happening. Yeah.
Correct. Okay. Okay. By the end of the day, the cost of the NFT is still 8 ADA. There is 2 ADA that is just changing wallets,
Yeah.
basically, or changing where it exists in a UTXO. So that's all. So the buyer gets back NFT plus 2 ADA and the seller gets the 10 ADA.
Yeah.
Fair enough.
So yeah, it's hard to explain what is happening. We did it pretty quick, but there is this the seller is losing that 2 ADA that they locked, right?
Mm-hmm.
They pay that initially to lock it. It's there, and so when they sell it, they're selling the NFT plus that initial locked. So they want both of those values back. They want the ADA that they locked back plus the price. Now,
Correct.
you could write this the other way around where that value was just kind of consumed and lost by the buyer. And if they wanted to make it back, they could just do the price higher. Right, like they could just charge 12 ADA, and then that 2 ADA locked would like be null and void, and they would get their original 10 that they wanted back.
Correct. Correct. But that'll
But
be like extra work for the seller because now they'll have to see how much was locked and they don't know how
yes,
much would be locked before locking, all of that. Yeah.
yeah, and the point is here, this just happens. Like it's like you don't have to think about it, and it's a clean switch. Like nobody's losing
Correct.
or gaining more value than they should be. It's like really even. So yeah, cool. I feel
Yeah.
pretty good about this.
Yeah. I completely understand this as well. You both are cool as well, right? Newman and Lewis?
Yeah. That's. I mean, yeah. We got a little bonus at the end there. But we should wrap up. Let's no más lines. The DOMs are doming. It's beautiful
Yeah.
thing. Once again, we've met and we've generated value for our ecosystem. Just since over the recording and for people that are listening, hey, why not drop by the Gimbalabs? We're on Discord. Check out the other YouTube videos. There will be shorts created from this long session, and we will do it again next week.